Our world is governed by the rhythm of days, seasons, and years. We take for granted that a year on Earth is 365 days long. But what if a year was not 365 days? What if a year was almost twice as long? This is the reality on Mars, our enigmatic planetary neighbor. On Mars, a year stretches for 687 Earth days. This stark difference highlights the unique characteristics of Mars and its place within our solar system. It underscores the vast distances and celestial mechanics that shape the planets around us. Imagine experiencing 2 birthdays, while the Earth completes a single orbit around the Sun. This is the reality for a hypothetical Martian inhabitant. This difference in time isn't just a matter of curiosity, it has profound implications for our understanding of Mars and our efforts to explore it. Mars, often called the Red Planet, is smaller and less massive than Earth. It orbits the Sun at a greater distance than our planet. On average, Mars is about 142 million miles from the Sun, while Earth is about 93 million miles away. This difference in distance is the primary reason for the longer Martian year. The farther a planet is from the Sun, the longer its orbital path. Mars has to travel a significantly greater distance to complete one full orbit around the Sun. This longer journey directly translates to a longer year compared to Earth. Furthermore, Mars's orbit is more elliptical than Earth's, which is nearly circular. This means that Mars's distance from the Sun varies more significantly throughout its orbit. As a result, its orbital speed changes, slowing down when it is farther from the Sun and speeding up when it is closer. This variation in speed also contributes to the length of the Martian year. Much like Earth, Mars experiences distinct seasons. These seasons are a result of the tilt of Mars's axis of rotation, which is tilted at an angle of about 25 degrees, similar to Earth's tilt of 23.5 degrees. However, the seasons on Mars are much longer than those on Earth, each lasting roughly twice as long. This is a direct consequence of the extended Martian year. Spring and summer are the longest seasons on Mars, with summer in the southern hemisphere being particularly long and intense due to Mars's elliptical orbit. During this time, the southern hemisphere is tilted towards the Sun, while Mars is also closer to the Sun in its orbit. The longer Martian seasons have significant implications for the planet's climate and weather patterns. For example, the polar ice caps, composed mostly of water ice with a covering of carbon dioxide ice, grow and shrink dramatically with the changing seasons. During Martian summer, a significant portion of the carbon dioxide ice sublimates, directly transitioning from a solid to a gas, which contributes to variations in the Martian atmosphere. Section 4. Unveiling the mysteries of Mars. Mars has captivated humanity for centuries. Its reddish hue, visible even to the naked eye, has sparked countless myths and legends. Today, Mars is a prime target for scientific exploration, and understanding the Martian year is crucial to unraveling its mysteries. NASA, the forefront agency in space exploration, has been at the heart of our journey to understand Mars. Its Mars exploration program seeks to answer fundamental questions about the red planet's past, present, and potential for harboring life. One of the primary objectives of NASA's Mars missions is to search for signs of past or present life. The longer Martian year and the distinct seasons it creates provide a unique opportunity to study the planet's potential for habitability in greater detail. By studying the Martian climate, geology, and atmosphere across different seasons, scientists can gain a comprehensive understanding of the planet's evolution and its potential to support life. The discovery of liquid water on Mars, albeit in small amounts and under specific conditions, has further fueled the search for life beyond Earth. Section 5. Navigating time on a distant planet. For robotic missions to Mars, keeping track of time is not just a matter of scientific curiosity, it's a mission-critical task. The success of these missions hinges on the precise coordination of activities between Earth and Mars, which are separated by vast distances and operate on different timescales. To manage the challenges of timekeeping on Mars, NASA has adopted the concept of a sol. A sol is a Martian solar day, which is slightly longer than an Earth day, lasting 24 hours, 39 minutes, and 35.244 seconds. Sols are the fundamental unit of time for Mars missions, dictating the rover's operations, data collection, and communication schedules. However, coordinating Earth time and Mars time presents significant challenges. The time it takes for a radio signal to travel between Earth and Mars varies depending on the planet's relative positions in their orbits. This time, delay can range from about 4 minutes to over 20 minutes, making real-time communication impossible. To overcome this, commands for rovers are carefully planned and transmitted in advance, taking into account the Martian sol and the communication delay. This requires a deep understanding of the Martian environment, its seasons, and the rover's capabilities. Section 6. Bridging the gap between worlds. As we set our sights on sending humans to Mars, the challenges of timekeeping become even more complex. Unlike robotic missions, human explorers will experience the Martian year firsthand, and adapting to this new rhythm will be crucial for their physical and mental well-being. The concept of a 687-day year, with seasons twice as long as Earth's, would require a fundamental shift in our perception of time. Imagine celebrating birthdays every 2 Earth years or experiencing extended periods of daylight or darkness. To address these challenges, establishing a dedicated Mars calendar would be essential. This calendar would need to account for the Martian sol, the length of the Martian year, and potentially even the different seasons. Such a calendar would not only provide a practical framework for timekeeping, but also foster a sense of place and connection to Mars for future human inhabitants. It would mark the beginning of a new chapter in human history, one where we adapt to the rhythms of a different planet. Section 7. A glimpse into the future of exploration. Understanding the concept of a Martian year extends beyond the realm of scientific curiosity. It serves as a stepping stone to comprehending the vastness of our solar system and the diversity of celestial bodies that reside within it. As we venture further into space, encountering planets and moons with their unique orbital periods and rotational characteristics, our understanding of time will continue to evolve. We will encounter worlds where days are longer than years, where seasons last for decades, and where the concept of time itself takes on a whole new meaning. The exploration of Mars and the challenges of timekeeping serve as a testament to human ingenuity and our relentless pursuit of knowledge. It highlights our ability to adapt to new environments and overcome seemingly insurmountable obstacles. As we stand on the cusp of a new era of space exploration, the lessons learned from Mars will undoubtedly guide us as we venture further into the cosmos, pushing the boundaries of human understanding and expanding our horizons beyond the confines of our own planet.